Hey everybody, welcome back. Statics class, Friday. Short little lecture on some vector work. So hope everything went well this week. We did a lot and we're going to do a lot more. So it moves quite quickly at a pretty good pace. So if you got questions, you want to get those answered before you get buried too far along. I want to talk about adding vectors, a couple different methods that we're going to use. This is also in the book, so if you need to kind of double do it, check the book out. We can add vectors tip to tail like I've shown in class. If you have 3 vectors, you add them tip to tail, it's going to make some kind of crazy diagram, right? So I'll do it. I'll just make it really small. Like here's the 90 tip to tail, here's the 60, and then here's the 50. And often, they're not going to close. That just means there is a resultant. There is some effect left over. And then when I close it like this, that's the end effect, right? From here to here. And I'm guessing probably this way. But yeah, and these two necessarily are not in line. So if you have 3 or more vectors, the tip to tail method's not going to work. It's not going to make a triangle. It's going to make some irregular shape. If you have 2 vectors, it is going to make a triangle and it does work. So 3 or more vectors, you're going to need to use the component method. So the component method means you're going to find all of the x force effects for each vector and all the y force effects. And then you have 2 vectors after you do that, because you can sum them up when they're in line. Like all the x's are in line, you can just add them. You have to keep track of your negative and positive. That's important. But you can add them once they're on the x-axis. Same with the y. Once they're on the y-axis, you can just add them up, right? And that'll give you what we call the resultant x and the resultant y. So I'll go through this and kind of show you step by step. Sometimes you'll see folks do it tabular. I don't necessarily do it tabular, but you could think about making a table of x forces and a table of y forces and then adding them. That can work. All right, I'm going to scoot over right in front of my piece of paper here. I'll do x's first. So often it's written some forces in the x. So that's a little summation symbol right there, right? And then you just can write them, right? Once you figure them out. So this is pretty straightforward. We have the 90 all in the x, and that's in the positive x direction. So I'm going to put plus. Then there's this one, and this is the x component of the 50. So I'm going to write it f x of the 50, right? Here is the y component, f y of the 50. So those two add up together, tip to tail, to make the 50, right? So I need this x component. So I'm going to take the cosine because it's adjacent. And I'm going to write cosine 47 degrees equals adjacent fx 50 over 50 newtons. That means that the x force of the 50 Newton force is equal to 50 times the 47 cosine. 34.0, lots of 9s. Right, newtons. And which way does that point? It points negative. I'm doing that force, so it is pointing negative. So now I'm going to put it in my equation, negative 34.0999 newtons, right? So I have this one and I have this one. What's the x force of the 60? 0. I like to put it in the equation because if you have 3 vectors, you should have 3 components. You don't have to, that's just me. And that's gonna be 55.9000. And then there is an 8. So I'll just add it because that's not my answer, right? So I want to keep that precision going. All right. So let's keep going here. That is the summation of the x. I have them all, 1, 2, and 0 for this one. So now I need to do summation of the y. Same process. I have the 60 down. Pointing, if it points down, it's negative. If it points up, it's positive. And then I have this one, right? Which is going to be, and I'll just write it over here. I'll use opposite sign. So it's sine 47 equals Fy 50 over 50 newtons, right? Fy over 50. So then Fy of this 50 Newton force is going to be 47 sine times 50. 36.56 768, right? And that also goes up. So you do have to be able to draw these tip to tail, right? Or you have to understand that this has up effect, which is positive. All right, 36.56768 newtons. All right, so what that gives us, and then of course the 0 for this one plus 0, that gives us this y effect, the total y effect. So it's going to be 60 minus that, or the difference of, so I'm just going to go like that. Okay, actually it is 23.4323. And it is negative. Okay, so this is what we call our x, because the resultant is the leftover effect. That is the effect of these 3, right? And then this is our y. So these are the components of the resultant, or the addition of these 3 vectors. Okay, so I like to draw it, right? So this one is positive x 55, so that's this. Positive x, so there's our x. And this is negative y, about half. So I'm going to draw it about half. So there it is, the 2 effects. Sometimes we need this, right? So this is valuable, but often what we really need is this. See if I can get it here. Yeah. And that is R, right? And this can move over here. This really should be our X up here, our Y over here. Let me fix my notation a little bit. Right. So I just plop this one over here to build the triangle. I do not know that angle. I don't know it, but I do know both sides, right? I know our X and I know our Y. So I can get R just from Pythagorean theorem. Because it's a right triangle, because I'm using X and Y's. So I'll get that. I'm not going to write the actual equation. I'll just use the numbers. I need to square the 23. And I need to put the 55.8 and square it, and add the 2 together, and then take the square root of. So it looks like R is 60.61, and I am going to round it now, newtons. So remember, that's the magnitude. I need 4 things. I need the magnitude. I need the sense. So I have that. That's that right there. I need the point of application. So whatever, this was, I'll say it's A. So then this is A. And then I need the line of action, which is the angle in which it acts on. That's this angle right here. So you got to find that. So you have to have all four: magnitude, sense, direction, and point of application. So I need this. So I will use tangent, unknown angle theta, and I'll say it's equal to Ry over Rx. All right, so I'm going to crunch that real quick. $22.74 degrees. All right. So now I have everything I need. I can write the solution. R, which is the resultant, that's what we call that resultant effect of these three forces, equals 60.61 newtons. And then I just write at an angle of, and I use my symbol for that. And I have my sense in here now. Everyone knows it's down and to the right, an angle of 22.74 degrees at point A. That's everything. That's the whole solution. Okay. So if there's 10 vectors all happening at the same point, this is key. These are all at the same point. This is called a concurrent force system where all the forces are concurrent. I can use the component method to find the resultant of those three forces. So we will do a lot of this, lots of practice. So I'm going to put up the homework set and have you do one of these over the weekend. So good luck. Let me know if you have any problems with it, and have a great weekend.